Hi guys, and welcome to another video in the HSC Chemistry series from the acidic environment, and this one looking at defining acids. There's a couple of important things that we need to do in this video, so I'll try and shorten it a little bit, but I know it may run on, so apologies up front. Firstly, we're going to slightly start shifting our definition of acids now to being chemical substances which can donate a proton, and the reason for that is very simple. A proton is a hydrogen ion. So when the hydrogen atom with one proton in its nucleus and one electron around the outside becomes ionized, it loses that electron. So all that's left is a proton in the nucleus, and hence a hydrogen ion is the equivalent of a proton. When any acid solution is prepared, the acid molecule ionizes by donating that proton to a water molecule. So in actual fact, we don't have these individual protons racing around a solution. What we have is a protonated water molecule. And this is going to become a little bit more evident later on. But let's have just a quick look at it for the moment. So this protonated water or hydrated proton is called a hydronium ion. Effectively, what has happened here is the water molecule has taken in that proton and formed the hydronium ion. And this is going to be very important. It's the one that we're actually referring to every time we talk about things like pH. So this means that we need to slightly change the way we've written our ionization formulas in the past. So you'll notice that previously, we just looked at ionization of HCl as producing H+ ions and Cl- ions. Now, in order to write this correctly, we're going to have to put the hydronium ion and the chloride ion. Likewise, for nitric acid, the hydronium ion needs to be identified in aqueous, and then the anion, which in this case is the nitrate ion, and I didn't put aqueous for that one. And then for sulfuric acid, this time, there's two ways of looking at this particular one that I want to just have a quick look at. So the first thing I'm going to do is I'm going to simply ionize the same way I did above. What this leaves me with is an HSO4- ion. This is the bisulfate or hydrogen sulfate ion. Now there can be a further ionization so that effectively we can produce two H3O+ ions and an SO42- ion. But this is something that we'll be having a look at a little bit later as we go along. So the ability of acids to donate protons provides a better definition, and we're going to link this to something called the Bronsted-Lowry definition. But I'll explain that a little bit more in a subsequent video. What it means is that we're going to try and get our heads around the fact that acids are actually proton donors. They are substances which will donate protons to other substances, and this includes water. When they ionize water, the reaction is often simplified, and that's the version that we've been looking at up till now. So we just need to make sure that we're aware of the fact that these two terms are effectively interchangeable the way that we use them, but it's more correct for you to actually use the hydronium ion rather than the H+ ion. So a couple of little definitions then we need to look at. The two things that really describe acids are their strength and their concentration. The strength refers to the degree of ionization of the molecules. That is, how readily those acid molecules produce the hydronium ion and the anion. Sulfuric acid is regarded as a strong acid. This is because it completely ionizes. The concentration of an acid is the second descriptor, and it refers to the ratio of acid to water in the solution. So a 10 molar solution of sulfuric acid is a concentrated acid solution, a lot of the acid in water. It also happens to be a strong acid as well. We can compare acids and bases on those two important qualities, their degree of ionization and the relative amount of water in the solutions. So let's look at acid strength. The first thing we need to be aware of is that not all acids completely ionize, such as hydrochloric acid or sulfuric acid. Some of them only partially ionize. And that's where we need to be aware of the differences between the strong and the weak acids. So hydrochloric acid and sulfuric acid are two acids which readily ionize completely. Weak acids do not. So a lot of the organic acids do not, such as acetic acid, CH3COOH, the key component in vinegar, and also hydrogen fluoride. Now, hydrogen fluoride is an interesting case because you can see it over on the diagram that I've included. Here we see a number of molecules of HF. The little blue ones indicate the hydrogen ions. The larger green ones indicate the fluoride ions, and then an intact molecule is the hydrogen fluoride. So this is the H plus ion and this is the F minus ion. Notice when we look at the comparative amounts of each, there is a very large amount of the HF and only a small amount of each of the two ions. So this is only partially, I'll have to move that across, partially ionized and not fully ionized, and therefore it's a weak acid. So this relative amounts of the molecule and its ions are what tells us whether or not the acid is a strong or a weak acid. In terms of concentration, we're simply talking about the ratio of acid or H plus or even H3O plus ions to water in the solution. Dilute acids have a very low ratio and concentrated acids have a very high ratio. So a 17 molar solution, a 10 molar solution, these have high acid to water ratios, whereas a 0.1 molar solution, 0.01 molar solutions have low acid to water ratios. So we're going to have a look at some examples of the ways in which acids can be classified on the basis of their strength and also of their concentration. But we'll have a look at this in class. Thanks for watching.